This video is about fitting a set of caster wheels to my wood bandsaw. Hello, my name is Bob, and once again I would like to welcome you to another episode on the White Dog Garage YouTube channel. If you've watched any of my woodworking videos, you will have noticed that I work in a tent workshop, tent wood shop as I like to call it. No sawdust is allowed in this garage. It's a metalworking shop in here. Anyhow, setting up the tent wood shop takes a fair bit of lifting and carrying, and things like the bandsaw, a bit beyond lifting and carrying. I suppose I can lift and carry it, but I use a trolley to wheel it out. It needs a set of wheels, and that's what this video is about. I am making the wheel frame out of 50 by 50 by 6mm or 2 inch by 2 inch by 1/4 inch mild steel angle, which I am cutting to size using my dry cut saw. I'm using my bandsaw to cut 4 102mm long or 4 inches long pieces from a length of 100 by 8mm or 4 inch by 5/16 of an inch mild steel bar. These will be used to make the caster mounts. I am mounting the casters on outrigger arms from the frame cross members. This means the side members need to intersect the cross members. To enable the two angle pieces to mesh together, I will remove the bottom section of the side member where it intersects the cross member. I use a piece of scrap angle to mark out the metal to be removed. Can you spot the mistake I've made here in positioning the cross angle? It'll become obvious when I go to weld it up. I use my jigsaw to remove the bottom section from each end of the side members. The wheels I'm going to use are these here. They're industrial casters. They've got a blue elastic rubber tyre, quite solid. front ones will swivel and the rear ones are straight. I've used these before, quite happy with them. I like the rubber tyre because it runs a little easier on concrete, and the wheels are 100 millimeters in diameter, which means they'll easily run over the various uneven surfaces that I intend to use this trolley on. I have stack welded the 4 caster mounting plates together, and I'm using one of the casters to work out where the holes for the mounting bolts will be drilled. I use a scribe to transfer the caster's hole pattern to the top plate, and then use a centre punch to mark the positions where the holes for the bolt threads will be drilled. The 4 plates have been welded down one side to form a stack. That is, the 4 plates are placed one on top of each other, their sides aligned, and 2 beads of weld are run down one side of the stack. This holds the stack together, or in this case stack drilling of the mounting holes for the casters. The plate stack is placed in the drill press vise, resting on 6mm thick spacers to prevent the drill damaging the vise. The holes are being drilled at a diameter of 6.8mm. Back at the bench, I check that the holes line up with the caster mount hole pattern, and I then use a grinder to remove the weld beads and subsequently separate the plates.
Levels. It's cramp relief in a tablet. Cramping.
Each plate hole is then tapped to produce an M8 thread, that is, a thread with a diameter of 8mm and a pitch of 1.25mm. As each thread is produced, it is checked by screwing in an M8 hex bolt. With the 4 frame members and the caster mounting plates prepared, the frame is assembled for welding. It is only now that I discovered that I had removed too much metal from the bottom of the side members, resulting in large gaps where the side members meet the cross members. This was caused by using the outside instead of the inside of the angle to mark the cutout section, resulting in a bigger gap, approximately the thickness of the angle, 6 millimeters. Saves beveling the joints, I guess. But in part 2, I'll tell you how my electrode choice worked to help me fill the gap. After tack welding the joints, it is then a process of welding them out, using a mixture of vertical fillet, horizontal fillet and flat butt welds. Thought I'd cover a couple of points before I go on. One of them is about layout. I don't have a welding table. Some places I've worked at, there have been welding tables. Other places there haven't been. They're not absolutely necessary. Sure, you don't really want a wooden bench because you end up with little fires everywhere, but some sort of metal bench certainly helps, and as you get older it's nice to have it up off the floor. Anyhow, in this case I'm using just an aluminium platform. Now it's not particularly wide, and to get around that I just use some pieces of box tubing. I lay it across and just place the important points on the box tubing, and it all works out. Lots of access, no problems. The other point I want to cover is the use of clamps. If you think back to when I started in this, there are a lot of clamps in action. You want to leave those clamps in place as long as you can. The reason being that every weld you do distorts the metal, or will cause a distortion in the metal. If you leave the clamps in place, the welds, the cumulative welds, end up fighting against each other, and you're likely to get to the end with minimal or no appreciable distortion. If you weld a simple T-piece, you clamp it all down, and you weld around the base here, I can't guarantee that when you spring those clamps there won't be a bow in this. But generally, the more pieces that go to make up the frame, the more likely it is that when you pull it out of the clamps you'll have minimal distortion.